This problem says that the TV remote in your house takes two AA batteries, and both batteries must not be dead in order for the remote to work properly. You have a box of new batteries, but you know your roommate accidentally put some dead batteries in the box. Now they're mixed up. We have a total of 15 batteries, and 4 of them are dead. We are asked to find the probability that both batteries are new. So we begin with 4 dead batteries and 15 total. It would help if we knew how many batteries were live. So to find the live batteries, we can just take 15 and subtract 4. 15 minus 4 is 11, telling us 11 of the batteries are live. Now let's first find the probability of drawing our first live battery. Now the probability of drawing a live battery is going to be the number of live batteries divided by the total. We have 11 live batteries and a total of 15, so in this box we can type equals 11 divided by 15, giving us a 0.7333 probability of drawing one live battery the first time. But remember that this is going to be a 2-event chain because we have to draw 2 batteries. That means we'll need to calculate 2 probabilities. Now, also, if one of the batteries is taken out of the pile and is put in our remote, that means that we have not replaced the battery in the pile. So we can say this is without replacement. So to find the probability of getting the second live battery, we now have only 10 live batteries left in the pile because we used to have 11 and we've already taken one out. Also, we used to have 15 total batteries, but we've taken one out. This gives us 10 over 14. So our probability is equals 10 divided by 14. Now to find the overall probability of both events happening in a row, we just multiply. We'll take the first probability, multiply by the second probability. This will give us 0.52381 probability that both batteries will be alive. Paint this gold, and we'll reduce the number of decimal places. We can do the same thing to find the probability of both batteries being dead. So let's find the probability of having the first dead battery. Now we have a total of 4 batteries in the pile that are dead. So we'll say our dead batteries are 4. But to find the probability, we divide by the total. Now, we're going to reset the count from last time, and we're going to have 15 total batteries again. We're not going to use our results from Part A to carry over to Part B. We'll still say there are 15 batteries total. We'll say equals 4 divided by 15, giving us this probability. We'll reduce decimal a few times as well. Now let's find the probability of getting the second dead battery in a row. Now that we've taken one of the dead batteries and put it into our remote, we don't have 4 dead batteries anymore. Now we only have 3. And also, we no longer have 15 total batteries because we've taken one out and put it in our remote. We now have 14. So now, to calculate the probability, we'll say equals 3 divided by 14. This is the probability that the second battery is also dead. Now, we multiply. We'll just take the first times the second. Click the first probability, multiply by the second. This gives us a probability of 0.057143. Again, let's reduce the decimals. So this is about a 5.7% probability that both batteries will be dead. This is going to be a slightly more complicated situation. Now we find the probability that at least one battery is dead. Let's go over the outcomes for these two events before we go any further. Now, one thing that could happen is we could have both batteries dead. We know this is 0.057. We could have both of them be alive. We calculated that probability in part A. That probability was 0.524. Now, we could also have one of them alive and one of them dead. Now, we haven't actually calculated this yet. However, let's go through the outcomes that fit this description. When they say at least one battery is dead, at least means one or more. So the outcomes that fit that description are the outcome where they're both dead and the outcome where one is alive and one is dead. However, there is one outcome that does not fit that description, the one where they're both alive. Now, it may look like it could be a problem that we don't know the probability for one being alive and one being dead, but it turns out we don't have to. To find the probability of the two green ones, all we have to do is take 1 minus the red one, and all that's left is green. Now, thankfully, we've already calculated the probability in red. So let's place it down here as well. So the probability that both of them are alive was calculated in part A. We can retrieve that number from part A. It was 0.524. Now, to find the probability that they are not both alive, we can take equals 1 minus the 0.524 that was in red. When we press enter, we'll find we have 0.476. This is the probability of having either both dead batteries or one dead battery. Whereas the 0.524 was the probability that none of them are dead. So even though we don't know all of the probabilities, we do know which probability we're meant to exclude. The most tricky part of the wording is the at least. If you looked at the words at least and didn't realize that meant one or more, it would be very difficult to realize that you're meant to exclude the probability that they're both live.